In this video, we'll explore how to run the structural analysis and review the design results step by step in ideCAD Structural. You'll learn how to switch between the solid and analytical model, visualize deformations, and review loads and internal forces. We'll also check steel and composite member design results, understand PMM ratios, and verify connection performance. By the end of this lesson, you'll know how to perform, inspect, and validate a complete structural analysis with confidence. At the top right corner of the toolbar, there is a lightning-shaped icon. This is the shortcut for the analysis and design command. Alternatively, you can just press F9 to start the analysis. A confirmation dialog will pop up asking if you want to proceed. Once you click Yes, the analysis will begin. In the analysis window, you can track the progress step by step and see which operations are being performed. The analysis has now completed. There are two main ways to review the analysis results. The first one is from the Structural Inspection section in the top ribbon menu. The other way is to right-click in the Perspective window and choose Analysis Model from the context menu. We're now inside the Analysis Model view. When the Extrude option is enabled, you can examine the building as a solid 3D model. If you disable it, you can switch to an analytical representation of the frame elements, like beams and columns. We'll begin by exploring the Analysis Model tab on the left vertical toolbar and its sub-options. Let's begin. There are buttons to toggle nodes and links and to display node numbers. Since the screen is a bit crowded, I'll hide the node numbers for now. The Show Links option visualizes the connections between nodes. The Show Supports checkbox is currently on. If we zoom into the bottom ends of the steel columns, you can clearly see the support symbols, which show that the columns are fully fixed at the base. This matches the fixed base condition we defined for the moment-resisting column-to-foundation connection. If I uncheck the box, the support symbols will disappear from the view. If you'd like to verify the member names, you can enable the Show Member Names option. You can also toggle local axes for each structural element. Similarly, degrees of freedom, DOF, can be reviewed in detail. The circular blue and green symbols indicate which rotational degrees of freedom are released or active. These indicators are critical for validating boundary condition and release definitions. If you've defined moment releases on any beam or column or created steel connections, always inspect the DOFs visually here to make sure your definition is correctly applied. Keep in mind, when Extrude is enabled, DOF visuals may be harder to see, but you'll still get a better view of the building's geometry and layout. If you want to display diaphragms in the analysis model, simply enable the corresponding checkbox. Next, let's move on to the Deformations tab. To better observe the results, let's enable the Extrude mode for a solid 3D view of the model. At the top of this section, you can again toggle the nodes and links to make the structural connections visible. The support symbols can also be displayed here. Currently, we are viewing the overall displacement results through a colored contour. If preferred, you can also switch to the hot contour color scheme. By default, the deformation type is set to U, total displacement, showing the overall displacement magnitudes in the structure. If necessary, you can isolate the displacements in the X, Y, or Z directions individually. In the drop-down list below, you can select any load case or load combination to review the corresponding deformation results. You can click the Animate button to animate the deformation behavior. This helps you visualize the dynamic behavior of the structure under the applied loads. Reviewing both modal and vertical deformation results is especially critical for identifying potential modeling mistakes. Because for users who are new to the software, this stage helps identify modeling mistakes, such as missing or incorrectly placed nodes, or incorrectly defined connections. For example, if a steel member isn't properly connected to its intended node, it may appear to extend infinitely in the analysis model, a clear indication of a missing or misaligned node, and a common modeling error. In some cases, the software may even be unable to complete the analysis and issue a warning. Let's start by examining the modal analysis results. I selected the modal load case, and in the top left corner of the screen, we can see the corresponding period and frequency of the mode. I hit the Animate button again. Below that, the arrow icons let you switch between modes, so we can preview Mode 2, Mode 3, or quickly jump to the last or first mode in the modal analysis. This section allows you to browse all available load cases and load combinations used in the project. An important note, even if the model doesn't include concrete elements, the software still automatically generates concrete design load combinations based on the selected concrete design code. That's why you may still see concrete-based combinations in the list. As you know, for the design of steel members and connections, the software uses the selected steel design code, such as ISC 360 or Eurocode 3. Let's continue exploring the list of load cases and combinations. At the top, you'll see the dead load and live load cases. Just below that, you'll find G and Q, which indicate that the calculations were performed using cracked section properties. Scrolling further, you'll notice Fx, Fy, and their variations. As you know, these represent lateral forces calculated using the equivalent lateral force, ELF, method, which is applied in the irregularity checks as required by seismic codes. Below that, you'll see the wind load cases. You can go through each of these and review all the corresponding analysis results. Now moving on to the Loads tab. This section allows you to review all the different types of loads applied to the model. At the bottom, there are several filter checkboxes where you can toggle to display nodal loads, frame element loads, shell loads, moments, forces, or simply choose Show Both. At the very bottom, a drop-down menu, Load Cases toolbar lets you switch between different load cases. Since we started by applying only dead loads, you'll only see results listed under G for now. There are no custom user-defined loads in this model, so nothing is displayed in that regard. Soil pressure and hydrostatic loads are also not defined here. Let's start by looking at the sheeting loads. These are the results calculated automatically by the software based on the relevant wind code. For example, when reviewing the wind loads, you can see the loads in the positive and negative X and Y directions, in accordance with code requirements. When we select wind loads acting on elements, we can observe that the wind pressure has been applied to the columns and distributed across the horizontal girts. Again, you can use the Load Cases toolbar below to toggle between various loading scenarios. Let's take a look at the snow loads. In this case, no snow load was applied to the sheeting, so there's nothing to display. Similarly, since no additional wind or seismic loads were assigned to the diaphragms, these results also appear empty. If we now check the loads acting on the purlins and ties, we can see the self-weight loads. Under the sheeting load category, the results are listed for dead loads, live loads, and all wind load cases. This is how we can review the reactions on purlins and ties. The wall loads we defined earlier from the Loads tab in the Steel Beam menu are now shown here. Let's now move to the slab loads. If we inspect the area where the slabs are placed, we can also see both dead and live loads applied accordingly. That completes the Loads tab. You can use this panel to verify whether all the applied loads were defined and distributed correctly. Now, let's move on to the Frame Results tab. Here, you can examine axial forces, shear forces in the 2-to-2 and 3-to-3 directions, torsional moment, as well as bending moments in the 2-to-2 and 3-to-3 directions. The drop-down list for load cases is available at the bottom of the screen, allowing you to select any load case or combination to view the results in detail. To examine a specific member in depth, simply click on it once. Let's take a look at the result window that pops up. You'll see the selected load case or combination at the top. You can easily switch between them using the drop-down menu. Just below that, the software displays the calculated axial force value along with its unit. You can also review intermediate results for any specific point along the member. Next, you can check the major direction shear, minor direction shear, torsion, and both major and minor bending moments. At the top, just below the Show button, you'll see 3 viewing options: Max Positive, Max Negative, and Max Absolute. You can use these toggles to customize what you're reviewing. Earlier, we looked at the results for a steel column. Now I'll click on a steel beam. Since the interface is the same, I won't go into the same level of detail again, but the process for reviewing beam results is identical. Let's move on to the purlin results. By switching to the appropriate load case, you can examine how loads are distributed across the purlins as well. Now let's go into the Steel Design tab. To begin, click the top option to verify the input data. Once you click the Design Input checkbox, the corresponding drop-down menu is activated. Let's go ahead and explore it in detail. It starts with the material assigned to the member. As you can see, the material is displayed on screen. Since only S235 was used in this project, all members appear in red by default. Just below that, you can see the cross-section assigned. All sections used in the model are listed on the left. For example, you can verify whether all purlins were defined using the same section. This is a great way to validate your input. You can also view member lengths and their corresponding capacities here. The software provides detailed data on major axis bending capacity, minor axis bending capacity, major shear capacity, minor shear capacity. Note that we haven't applied any snow load in this model, so snow-related effects are not shown. As for the connection plates, we used S235 across all joints. At the very bottom, you'll see the weld electrodes. If you recall, we defined two types, E480 and E510. Both are shown here. Now I'll check the design output box and begin reviewing the results. Currently, all failed members are highlighted in the perspective view. At the bottom, you'll see 3 additional toggles. Show values. Show purlins. Extrude elements. These allow you to further customize the design visualization. To get a clearer view, activate the Extrude Elements and uncheck the Show Purlins box. This allows you to focus more easily on the results. Let's go through this step by step. At the top of the drop-down menu, we have the PMM ratios displayed. On the left, you'll see the corresponding color scale. Overall, the PMM ratios for our members look satisfactory, no major issues here. This allows for a quick overview of the entire model. Now let's take a closer look at the composite members in our model. As you know, we have a castellated beam and composite elements as part of our composite slab system. Along with the PMM ratios, we can also review the shear ratios for both the major and minor directions. Currently, they're all showing blue, which indicates low utilization. Next, I'm going to reset the view and select a column. Let's inspect a couple of members more closely. If you want to manually review any member, especially if you notice a warning or failure, simply click on that element. Once a member is selected, the software will display its name, section, material, PMM ratio, and the specific load combination that governs the result. Below that, you'll find the shear utilization ratios for both the major and minor axes, each linked to their respective governing load combinations. All checks are passing, indicated by green check marks. A slenderness check is also included here. For this example, the slenderness limit is 200, and the member satisfies the requirement. Now, if I click the Detail button at the bottom, a more comprehensive report window opens. At the top, you'll see which design code is being used. Right below that, we have the section properties, section area, moments of inertia, and radius of gyration. Then comes the material info. For S235, you can see the yield strength, ultimate strength, and modulus of elasticity. In the summary section below, you'll find the forces and moments used in the design checks. These are directly derived from the internal forces calculated during analysis. The software automatically loads the governing combination first, but of course, you can switch between combinations to compare results if needed. Just below, you can see the demand/capacity, D/C, ratios. In this example, the D/C ratio is 0.146. The governing equation and the corresponding code reference used in the design are also displayed. Shear design checks for both major and minor axes are also presented in a similar format. Further down, you'll find the results for axial force and biaxial bending checks. The internal axial force, along with the tension and compression capacities, are shown here. Likewise, the bending moments obtained from analysis in the major and minor directions, along with their corresponding moment capacities, are listed below. The same applies to torsional moment capacity. On the right-hand side, you'll find the design factors used in calculations. The software uses the effective length method for stability checks. Therefore, for both major and minor axes, the K factors, effective lengths, and the member length are clearly displayed here. You'll also see the CB and LTB factor values used for lateral torsional buckling calculations. If you recall, during the modeling stage, we mentioned that these parameters can be adjusted from the Design tab for each steel member, such as columns or beams. This window offers a comprehensive breakdown of all stability-related design inputs. Clicking the OK button will close this tab. Whenever you encounter a design failure or warning, you can return to this screen to investigate the root cause in detail. Let's take a look at a composite beam example now. By clicking on one of the composite beams, the full composite beam list appears. This menu follows a similar structure. You'll find the member name, section, material, construction stage design results, composite design results, and deflection checks. The green check marks indicate that all verification checks are satisfied. If I click the box for construction stage design, a detailed window opens showing all calculated parameters: bending moment, shear gross, shear net, horizontal shear, and more. It also shows the internal forces used in each check and the section properties relevant to the analysis. The same process applies to composite design results as well. As you can see, this time the section properties shown reflect the composite cross-section, including the concrete slab. I clicked OK and exited the menu. Continuing with the design output options, the next item is PMM failure. I selected it, and the perspective view was updated. Now we can observe that some purlins and ties are failing in terms of combined axial force and bending moment capacity. Next, I checked shear force failures. No issues were found. All members are shown in green, indicating adequacy. There's also an excessive deflection issue on some purlins. While no axial force failures are detected. One section below, we see connection ratios and potential connection failures, which are also available for review. As I mentioned earlier, the second method to view the analysis results is through the Structural Inspection button on the ribbon menu. Once selected, it initially displays the solid model. Click again to switch to the Analysis model, which opens the Analysis Visualization tab. You can also switch to modal results from the upper toolbar, just as easily. Now, one important thing to note here: below the All Failures icon marked with a green arrow, you'll also see individual failure categories: PMM, shear, axial, and connections, all marked in green, indicating that all design checks have passed. You may notice red-colored elements in the background. These represent the purlins, which are intentionally excluded from the global analysis model, and therefore are not displayed in this window. As you may recall, purlins and ties are analyzed separately with their respective sheeting loads, and their internal forces are computed independently. These reactions are then transferred to the main structure, where they are included in the global stiffness and load matrices for analysis. Thus, the reason for not seeing red-colored members here is that those elements are outside the scope of the global analysis model. Thanks for watching. Don't forget to like, subscribe, and explore the knowledge base for more tips. See you in the following video.